I'm going to use a previous homework question to show you how to make a probability tree diagram. Let's take a look at the chart first. You can see that when you look at this chart and we're looking at it going horizontally, there's 154 men out of a total of 295. And looking at the females, there's a total of 141 out of 295. Now looking vertically, we have a total number of people that have cats. That's 151 out of 295. And the total number of people that have dogs is 144 out of 295. So if I wanted to make a probability tree diagram, I can either start with whether we pick someone that's male or female, or someone that has a cat or dog first. It doesn't really matter. You're going to get the same answer at the end. So I'm going to start by looking at picking a male or female first. When you make your tree diagram, you always want to, I call it the start button, but pretty much just make a dot of where you're going to start. And then since we're looking at picking a male or female first, I'm going to label this as male and this track as female. So these branches, this is what I call the first layer, because we're looking at whether we pick a male or female first. And when I look at the table, I can see the probability of picking a male is going to be 154 out of 295. Now, the probability of picking a female, that's going to be 141 out of 295. Okay, so that's our first layer. Now I want to narrow it down to whether the first person that's picked has a cat or a dog. And because we have two options for male and female, we're going to end up 4 in total, because we're going to have 2 options for male and 2 options for female. So when I look at the possibility of someone that's male that has a cat, let's label this as C for cat. So I'm making the assumption, I'm coming down the track this way. So I'm making the assumption that I already picked a male first. Now, out of the males, how many people or how many males have cats? So if I look at this row right here, I'm just looking at the males because I'm making the assumption that we already picked a male because of this first branch. Out of these males, the probability of someone having a cat, we have 59 over 154 for the probability of picking a cat, given that we already picked a male. So that's this branch here. Now I'm going to come down and look at what happens if I pick someone with a dog. So again, since I'm looking at the branch where I've already picked a male, so out of the men, looking at the people that have a dog, that would be 95 out of 154. So this is the probability of picking someone with a dog, given that we know we already picked a male. Now, let's look at the second branch over here for the females. We have the same options for the females. Once we pick a female, we can pick someone that has a cat, or we can pick someone that has a dog. So now, because we're coming down the second branch right here, I know my assumption is going to be that I've already picked someone that I know that is female. So now we're looking at this group right here, just the females. So looking at that group, how many people, if I know I already picked a female, what's the probability that I pick a cat? So that would be 92 out of 141, and that's the probability of finding someone that has a cat, given that we've already picked a female. Okay. So now we're going to do one last branch. What's the probability of picking someone with a dog that we know we picked it out of the female group, because we know we already picked a female. That's our assumption. So if we look at the group of females and we look at just the ones that have dogs, that would be 49 out of 141. So this is the probability that I pick a dog given that I already picked a female. All right, now let's come up with these probabilities at the end so we can see what our all of our possibilities are. So if I follow, let me use a different color here. If I follow this track, I pick a male first, and then I pick someone that has a cat, that would be a probability of picking a male and picking a cat. I just multiplied down the branches. So the first branch would be 154 over 295. And then I multiply by the second branch, which would be 59 over 154. And when I put that in a decimal format, we get 0.2. Now looking at getting a male and then a dog, now I'm coming down the first branch, but then splitting off to picking a dog. So this probability is going to be, we pick a male and we pick someone with a dog. So when I multiply down the branches, that gives me 154 out of 295 times 95 over 154. And when I multiply that out and get my decimal approximation, that's going to give me 0.3220. Now I'm going to do the same thing with the females now. If I come down this branch here for the females, if we then pick someone with a cat, that would be the probability of picking a female and picking a cat, and I just multiply down the branches. So I have 141 over 295 times 92 over 141. And when I multiply that out and get my approximation, I'm going to get, let's see, 0.3119. Okay, last one. I'm going to make the assumption that I pick a female first, and then I pick a dog, someone with a dog. So that would be the probability of picking a female and picking someone with a dog. And when I multiply down the branches, I have 141 over 295 times 49 over 141. And when I multiply that out and I get my approximation, that's going to give me 0.1661. What I would like you guys to do is take a minute and try it the other way, where you look at picking a cat or a dog first, and then you look to see if the person is male or female. So your tree diagram would look like this. What's the probability of picking someone with a cat or a dog first? And then you look at female versus male for each of those. And then find those probabilities. Those probabilities should match up with what we did up at the top here. So if I come down this track right here, the probability of picking someone with a cat and that they're female, that should be the same probability, let's see, as this one right here. This is the probability of getting a female and a cat. You should get that same value. Same thing. Let me go through one more. Let me pick something else here. Green. And if you find the probability of coming down the branch first where you know you pick someone with a dog, and out of the dogs, you then pick someone that's male, that should be the same probability as this right here, the probability of picking a male and a dog. So I would really suggest, just for practice, you try finding your probabilities this way and make sure that it matches up with my and statements from the first diagram. One thing I want to point out is that when you follow the whole path down one of the branches, and you just follow that whole path down, that's going to be your and statement where you multiply the branches together. If you're only looking at one specific branch, you're not following the whole path down, then you're looking at the conditional probability because you're making an assumption of what happened on the previous branch as you follow it down. So looking at this, if I follow this down, I'm making the assumption that I've already picked a male on that branch. And now this second branch is the probability that I pick a cat given that I've already picked a male. So that's just your conditional probability. And then when you follow the whole path down, that's where you get your probability of the and statement, the probability of getting a male and the male has a cat.